Hello, just did this question. It took way too long for me to do it, so I'm just gonna have to do it again. Don't want to edit that out. The frequency of an element is the number of times it occurs in an array. You're given a number k, which is the maximum number of operations you can do, and an operation is incrementing a number. To be able to get as many numbers as possible to be equal to each other, and then return the max frequency. So for example, for this question here, we can increment 1 3 times to make it equal to 4, and 2 times to make it equal to 4, so 5 moves in total. So the max frequency of elements would be 3 in this case. If the array is sorted, we actually know that the answer would be contiguous. That kind of makes me think there is a sliding window approach where I keep track of 2 pointers, I and j. So say for example, I have 2 pointers, I and j, and these 2 pointers essentially define the window. So in this case, 1 and 4. Sliding window takes O of n time. I need to in constant time figure out how many moves it takes for this subarray to be made equal. And then if that is too large, then I could increment I while it is too large until I get some value less than or equal to k. And then j would just increment throughout the whole array. So how do I figure out, given a window, what's the maximum number of moves? Since I can only increment elements, that means I have to increment all the elements other than the element at j within the window. And to do that, that would basically be equal to the sum of all elements within the window from I to j minus 1, in this case just 1, and then we subtract that from the total number of elements in the window from I to j minus 1 times the element at j. And that would be equal to how many moves we need to get the elements before j to be equal to the element at j. So the num moves in this case would be equal to j minus I. So that's the number of elements in the window not including j. And then I multiply that by the element at j. So nums at j. And I subtract the sum of elements in the window not including the element at j, which is ps, where ps is the prefix sums array. So prefix sums array at j minus the prefix sums array at I. In this case, our prefix sums array is 1 indexed. So in this case, I'm really just getting the sum of elements from I all the way up to j minus 1. Alright, so let's try and implement this. We have an array ps, a prefix sums array of size nums.size plus 1. Let's initialize the first value to be equal to 0, since it's going to be 1 indexed. We go through each of the numbers in nums. The prefix sum at I plus 1 will be equal to the previous prefix sum plus nums at I. Then our sliding window loop would be a for loop j that goes from nums.size plus j, and then we do a while loop for while the lagging index is less than j, and we have to check whether the total number of moves is less than or equal to k. Then if that's true, then we break out of this loop. So int num moves is equal to j minus I times the nums at j minus the prefix sums. So I'm just following the formula here, ps at j minus ps at I. Now if the num moves is less than or equal to k, then the window is valid, so I can break out of that. Otherwise, increment I. Let's keep track of the best answer so far. Let's make that 0. So the answer here would be equal to the max of the answer and answer so far, which is like j minus I plus 1. So after this while loop, I'm guaranteed that the window here at this point is valid. Then we can return the answer. Problem is, if you look at the bounds, and this got me the first time, we have 10 to the power of 5 is the max value of a num, and 10 to the power of 5 numbers. So a value in prefix sums could hold a value of 10 to the power of 5 times 10 to the power of 5, which is 10 to the power of 10, and that doesn't fit in an int. So we have to make this a long. And that also means that this value here we should make into a long as well. Use of undeclared unidentifier I. Let's also make that int I is equal to 0. I should really run it before I submit it. Okay, let's give that a go. Oh, and I forgot to sort it. That's the most important step. Nums.begin, nums.end. This should work. Yes.